The afternoon sun cast long shadows through the bocage hedgerows of Normandy as Oberfeldwebel Klaus Richter crouched in his Panther's turret, scanning the maze of earthen walls and ancient trees that turned every 100 meters into a potential killing ground. August 14th, 1944. The roads leading toward Falaise had become a graveyard of German armor, but Richter's crew in Panzer 337 had survived 3 weeks of this nightmare. Their faith rested on mathematics, on 80 millimeters of sloped steel angled at 55 degrees, creating effective frontal protection equivalent to nearly 140 millimeters of armor plate. The Tiger tanks possessed thicker armor, but the Panther's combination of firepower, protection, and mobility represented the peak of German tank engineering philosophy. Richter had commanded Panthers since the spring of 1943, first on the Eastern Front, where the long 7.5-centimeter gun could engage Soviet 34s at ranges exceeding 2,000 meters. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The weapon's high-velocity round traveled flat and true, punching through enemy armor with mathematical precision. German crews called it the finest tank gun in the world, and combat statistics supported their confidence. But Normandy had shattered every tactical assumption that defined armored warfare on the endless steppes of Russia. These hedgerows, some of them 12 feet high with earth banks reinforced by centuries of root growth, created a landscape where visibility rarely exceeded 200 meters. The Panther's long-range advantage disappeared in terrain that favored ambush over maneuver. American Sherman tanks, inferior in every technical specification, could approach within killing distance before German optics could acquire them. Worse were the invisible threats, the infantry teams with their portable anti-tank weapons that materialized from hedgerows like ghosts. Richter had encountered the American Dockinger rocket launcher 3 days earlier when his platoon advanced through the village of Mortain. The weapon appeared unremarkable, a simple steel tube carried by 2 soldiers who seemed barely old enough to shave. One man shouldered the device while another crouched behind, loading what looked like an oversized artillery shell with fins. The simplicity itself was offensive to German engineering sensibility, where proper anti-tank weapons required crews of 6 men and 15 minutes of setup time. This American contraption fired within seconds. The rocket had struck Panzer 339 on the turret side, 45 millimeters of armor angled at 25 degrees. The shaped charge warhead punched through the steel plate with devastating efficiency, creating a jet of superheated metal that killed the loader instantly and set the ammunition storage ablaze. The crew abandoned their burning Panther while Richter's machine gun cut down the American team before they could reload. But the tactical lesson was unmistakable. German Panthers, designed to dominate open battlefields through superior firepower and frontal protection, were vulnerable to infantry armed with weapons that weighed less than the ammunition stored inside each tank. The doctrine had been drilled into every Panzer commander during training at Paderborn. Panthers operated as mobile gun platforms, engaging enemy armor at maximum range while presenting the heavily armored glacis plate to incoming fire. The upper front hull, 80 millimeters angled at 55 degrees, could defeat Soviet 85 millimeter guns and American 76 millimeter rounds at all but the closest ranges. The turret front, 100 millimeters of cast armor in a curved mantlet, provided equivalent protection. Side armor was necessarily thinner, 40 millimeters on the hull and 45 millimeters on the turret, but German tactical formations emphasized mutual protection. Panthers advanced in sections, covering each other's flanks while maintaining fields of fire that prevented enemy infantry from approaching within effective range. Normandy rendered that doctrine meaningless. The hedgerows channeled German armor down narrow lanes where American infantry could position themselves within 50 meters of passing tanks. The Panther's weaknesses, acceptable in open terrain warfare, became fatal vulnerabilities in close combat. Richter knew every centimeter of his machine's protection scheme. The 40 millimeter side hull armor, angled at 40 degrees, could be penetrated by American 75 millimeter rounds at ranges exceeding 2,000 yards. The turret sides, 45 millimeters thick at 25 to 30 degree angles, offered slightly better protection but remained vulnerable to all Allied tank guns and anti-tank weapons. Most troubling was the 16mm engine deck armor that covered the massive Maybach power plant. Aircraft strafing attacks exploited this weakness routinely. British Typhoons and American Thunderbolts had destroyed more Panthers through rocket attacks on the thin top armor than through direct engagement with Allied tanks. But infantry with portable rockets represented a new equation that German armor doctrine had never anticipated. These American soldiers could appear anywhere, fire from positions that heavy tanks could not reach, and disappear before German machine guns could respond. The intelligence reports Richter had read during the brief respite at Argentan provided technical specifications for the American weapon. Designated the M9A, one rocket launcher, nicknamed Bazooka, after some American comedian's musical instrument. The system consisted of a two-piece steel tube, 61 inches long when assembled, weighing just under 16 pounds. Two soldiers operated the weapon, one as gunner and one as loader, though either could perform both roles with minimal training. The ammunition, designated M6A3, measured 19.4 inches in length and weighed 3.38 pounds. A shaped charge warhead containing approximately 1.5 pounds of explosive. German ordnance assessment concluded the weapon could penetrate 4 inches of armor plate at optimal angles. 4 inches translated to roughly 100 millimeters, sufficient to defeat the Panther's side armor with certainty and potentially compromise the turret front at close range. The shaped charge principle, focusing explosive energy into a narrow jet of molten copper, made armor thickness almost irrelevant within the weapon's effective range. Unlike kinetic penetrators that required mass and velocity to defeat armor, shaped charges created localized pressures exceeding 1 million pounds per square inch, burning through steel like a cutting torch through paper. What disturbed Richter most was the weapon's operational simplicity. German anti-tank doctrine required specialized crews, extensive training, and careful positioning. The Pak-40 anti-tank gun, which Richter had seen destroy Soviet tanks at Kursk, weighed 1,425 kilograms and required an Opel Blitz truck for battlefield mobility. 5 trained specialists needed 20 minutes to position the weapon for combat, longer when enemy fire necessitated camouflage. The gun's effectiveness was undeniable, capable of penetrating 100 millimeters of armor at 1,000 meters, but its mobility limitations made it vulnerable to counterfire and flanking maneuvers. The Americans had apparently asked a different question. Instead of building the most effective anti-tank gun, they had created a weapon that provided every infantry squad with immediate anti-tank capability. The Bazooka's 400mm effective range meant nothing in hedgerow terrain where engagement distances rarely exceeded 100 meters. Its crude optical sight, which German reports described as barely adequate for precision shooting, worked perfectly well when firing at a 45-ton target less than 50 meters away. The weapon's greatest strength was its universal availability. American infantry companies received multiple bazooka teams, creating a distributed anti-tank capability that German commanders found impossible to suppress. Richter's gunner, Unteroffizier Hans Steiner, had served with him since the Panther's introduction at Kursk. A Krupp metallurgist before the war, Steiner understood armor penetration mechanics with engineer's precision. During their maintenance halt outside Argentan, Richter had asked him to calculate the Panther's survivability against shaped charge weapons at close range. Steiner's analysis was methodical and deeply troubling. The bazooka's shaped charge created a jet of molten copper traveling at approximately 8,000 meters per second, far exceeding the velocity of any conventional anti-tank round. This jet, only a few millimeters in diameter, carried enormous energy focused into an infinitesimal impact area. When it struck armor plate, the superheated metal didn't punch through in the conventional sense. Instead, it created a hydrodynamic effect, with both the jet and the armor behaving momentarily like fluids under extreme pressure. The armor simply flowed out of the jet's path, creating a neat hole approximately 60 millimeters in diameter. The Panther's 40mm side hull armor offered no meaningful resistance. The shaped charge would penetrate completely, sending fragments of molten steel and copper into the fighting compartment where they could ignite ammunition, fuel, or hydraulic fluid. The turret sides, 45 millimeters thick, provided only marginally better protection. Steiner calculated that the M6A3 warhead would penetrate under virtually all combat conditions, with only extreme angles of impact providing any chance of deflection. Most concerning was the vulnerability of the turret ring, that critical junction where the turret rotated on the hull. Only 20 to 30 millimeters of armor protected this area, and any penetration here would disable the turret traverse mechanism while sending fragments directly into the crew compartment. The engine deck, just 16 millimeters thick, was essentially unprotected against shaped charge attack. A single hit here would likely penetrate both the armor and the engine block beneath, immobilizing the Panther instantly. Richter had asked the obvious question: what about the front? German training emphasized frontal engagement, where the Panther's sloped armor provided maximum protection. Steiner's answer offered cold comfort. The upper glacis, 80 millimeters at 55 degrees, created effective thickness of approximately 140 millimeters against kinetic penetrators. But shaped charges didn't care about angle in the same way conventional rounds did. The jet would still penetrate, though the extreme angle might reduce effectiveness. The lower glacis, only 60 millimeters at 55 degrees, was more vulnerable. The turret front, 100 millimeters of cast armor, should defeat most shaped charge attacks, but the curved mantlet created a shot trap that could deflect rounds downward into the 16 millimeter hull roof. The mathematics told a story that contradicted everything Richter had learned about armored warfare. The Panther, designed to engage enemy tanks at ranges exceeding 2,000 meters, was vulnerable to infantry armed with weapons that cost less than a single tank road wheel. German engineering had optimized for the wrong variables, prioritizing frontal protection and long-range firepower, while accepting side armor thicknesses that made close combat suicidal. The tactical implications were profound. In open terrain, Panthers could maintain standoff distance, using their superior gun to engage American Shermans before the enemy could close to effective range. But hedgerow warfare eliminated this advantage. American infantry could wait in concealment until German armor passed within 50 meters, fire their rockets into the vulnerable side armor, and disappear into the bocage before German machine guns could respond. The entire German tactical system, built on firepower and frontal protection, collapsed when forced into terrain that favored ambush over maneuver. Richter's crew had developed their own countermeasures through bitter experience. They welded spare track links onto the turret sides, creating makeshift spaced armor that sometimes detonated shaped charges prematurely. The Panther's earthen side skirts, 5 millimeter steel plates designed to defeat Soviet anti-tank rifles, provided minimal protection against bazooka warheads, but at least obscured the exact location of the vulnerable hull sides. Most importantly, they never advanced without infantry support. German Panzer grenadiers, when available, screened the tank's flanks and suppressed American bazooka teams before they could achieve firing positions. But infantry support was increasingly unavailable. The Falaise pocket had consumed entire divisions, and Richter's battalion operated at less than 40% strength. Individual Panthers often advanced alone, relying on their machine guns and the threat of their main gun to suppress enemy infantry. This worked until it didn't, until some American soldier with more courage than sense crawled within 50 meters and fired his simple steel tube at 45 millimeters of side armor. The afternoon air carried sounds of distant artillery, American 155s pounding German positions along the approaches to Falaise. Richter's orders were simple: hold this crossroads until nightfall, then withdraw toward the Seine. The Panther sat in a defensive position, hull down behind an earthen embankment with only the turret exposed to the road ahead. Steiner scanned through the Turmsee-Elfenrohr gun sight, searching for targets among the hedgerows that lined both sides of the narrow lane. The Americans came at dusk, using the long shadows to mask their approach. Sherman tanks, 3 of them, advancing cautiously down the road, with infantry spread out along the flanks. Richter let them close to 800 meters before ordering Steiner to fire. The first round struck the lead Sherman on the front slope, penetrating cleanly and igniting the ammunition storage. The tank stopped immediately, smoke pouring from its hatches. The second Sherman tried to reverse, but Steiner's follow-up shot caught it in the side as it turned. 2 kills in 30 seconds, exactly as German training prescribed. The third Sherman disappeared behind a hedgerow, and suddenly Richter had more immediate concerns. American infantry were in the field to his right, less than 100 meters away, moving through the tall grass in short rushes. He traversed the turret-mounted machine gun, firing controlled bursts that forced the infantry to ground. But there were too many of them, and they were too close. The Panthers' machine guns, designed to suppress infantry at range, couldn't cover all the blind spots created by the hedgerows and earthen banks. Richter saw the bazooka team emerge from a gap in the hedgerow, 70 meters to his right. 2 soldiers, one shouldering the tube while the other crouched behind with a rocket ready. They were inside his machine gun's arc of fire, protected by the angle of the turret. He screamed for the driver to pivot the hull, to bring the bow machine gun to bear, but 45 tons of Panther didn't turn instantly. The gunner had perhaps 5 seconds to aim, and Richter watched with the detached clarity that combat sometimes brings, knowing exactly what was about to happen and utterly unable to prevent it. The rocket motor ignited with a sharp crack, sending the projectile on a flat trajectory toward the Panther's right side. Richter lost sight of it in the last meter, but he felt the impact through the hull, a dull thump that seemed insignificant compared to the crash of anti-tank rounds against armor. Then came the secondary explosion, the shaped charge warhead detonating against 45 millimeters of turret side armor, and the world inside the Panther transformed into screaming chaos. The jet of molten copper punched through the armor plate as if it were paper, creating a pressure wave that struck Richter like a physical blow. Steiner, sitting directly in line with the penetration, died instantly as fragments tore through his position. The radio operator's scream cut off abruptly. Richter felt burning pain along his left side where metal fragments had caught him, but he was alive and the turret still turned when he grabbed the manual traverse. He knew the standard procedure. Abandon tank. Crew survivability took precedence over equipment preservation. But through the commander's cupola, Richter could see the American infantry advancing, could see more bazooka teams moving into position. Staying meant dying. Running meant dying. The mathematics that had protected him through 3 years of war had finally failed. The loader, Gefreiter Paul Hoffmann, youngest member of the crew at 19 years old, pulled Richter toward the turret hatch. The driver and bow gunner were already scrambling out through the forward hatches, and the burning smell of electrical insulation told Richter the fire would reach ammunition storage within seconds. He followed Hoffmann through the hatch, dropped onto the rear deck, and sprinted toward the tree line 30 meters behind their position. The Panther didn't explode, not immediately. The fire spread slowly enough that Richter and his crew made it to cover before the first ammunition rack cooked off. He turned to watch 45 tons of German engineering excellence transform into a funeral pyre, 3.4 pounds of American-shaped, charge explosive, having accomplished what no Soviet tank had achieved in 18 months of Eastern Front combat. Richter sat with his back against an oak tree, hands shaking from adrenaline and blood loss, while Hoffmann applied field dressings to the fragment wounds. The tactical situation was beyond recovery. His Panther was destroyed, his crew reduced from 5 men to 3, and American infantry controlled the crossroads. But the immediate crisis was merely tactical. The larger truth, the one that Richter's engineer's mind couldn't escape, was strategic and existential. German armor doctrine had been built on assumptions that American industrial philosophy rendered obsolete. The Panther represented the culmination of German tank design, optimized through years of combat experience to maximize survivability in frontal engagements at long range. Every design decision reflected careful calculations about armor thickness, gun performance, and crew protection. The result was formidable, on paper, and devastating in open terrain, where German tactical advantages could be employed. But the Americans hadn't tried to build a better Panther. They had asked a different question entirely. How could they give every infantry squad the ability to kill tanks? The answer was the bazooka. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. A weapon so simple it offended German engineering principles, so cheap that American factories produced 37,000 units monthly, so light that paratroopers could carry it into combat. The weapon sacrificed range, accuracy, and penetration against heavy frontal armor in exchange for universal availability and the ability to engage side armor at close range. In hedgerow terrain, where every engagement occurred at ranges under 200 meters and side shots were unavoidable, this trade-off became strategically decisive. German Panthers, superior in every technical specification, were being destroyed by weapons that cost 2% as much and required 2% of the training time. The tactical mathematics that favored German armor in open terrain reversed completely in close combat, and the hedgerows of Normandy provided nothing but close combat. Richter had read the production reports during the briefing at Paderborn. German factories, operating under constant Allied bombing and facing chronic shortages of strategic materials, managed to produce approximately 350 Panthers monthly by mid-1944. Each tank required thousands of man-hours of precision manufacturing, specialized steel alloys, and trained assembly personnel. American bazooka production, according to intelligence estimates, exceeded 37,000 launchers monthly, with General Electric alone producing more rocket launchers than the entire German weapons industry produced tanks. The strategic implications were mathematically clear. Even if German Panthers achieved favorable kill ratios, which they did in open terrain combat, the Americans could afford to lose. 5 Shermans for every Panther, while simultaneously arming infantry with weapons that negated German armor advantages in close combat. The numerical superiority, combined with tactical flexibility, created a situation where German technical excellence became strategically irrelevant. This wasn't the first time Richter had encountered American weapons that violated German engineering principles. The Sherman tank itself represented a philosophy that prioritized production speed and mechanical reliability over armor, protection, and gun performance. German tankers initially dismissed the Sherman as inferior, and by conventional metrics it was. The Sherman's 75mm gun couldn't penetrate Panther frontal armor at any range, while the Panther could destroy Shermans at distances exceeding 2,000 meters. But American factories produced 50,000 Shermans during the war, compared to 6,000 Panthers. The numbers transformed tactical inferiority into strategic victory. The bazooka followed the same logic, but more brutally. Where the Sherman at least required industrial resources comparable to German tank production, the bazooka could be manufactured using standard steel tubing and basic electronics. American workers who assembled radios could produce bazookas with minimal retraining. The weapon's very simplicity enabled mass production on a scale that German precision manufacturing could never match. Worse, the distributed nature of the bazooka threat meant German forces couldn't concentrate anti-tank defenses. Traditional anti-tank doctrine assumed that enemy armor would advance along predictable routes, allowing defensive guns to be positioned for maximum effectiveness. But bazooka teams could appear anywhere infantry could operate. Every hedgerow, every building, every patch of dead ground became a potential ambush site. German Panthers had to treat every meter of terrain as a threat zone, reducing operational tempo and forcing conservative tactics that surrendered initiative to American forces. The wound along Richter's ribs had stopped bleeding, though the field dressing was soaked through with blood and dirt. Hoffmann had done competent work, but proper medical treatment would require reaching German lines, assuming German lines still existed west of the Seine. The driver, Feldwebel Otto Kraus, reported that American infantry were moving through the area in company strength, systematically clearing the hedgerows that surrounded their position. Richter made the decision that tens of thousands of German soldiers would make in the coming months. Surrender would mean prisoner of war camps, probably in America, possibly for years after the war ended. But continuing to fight without armor, without supporting infantry, without any realistic prospect of affecting the tactical situation, meant dying in a hedgerow for no purpose beyond delaying the inevitable for perhaps another hour. The 3 survivors of Panther, 337, emerged from the tree line with their hands raised, following the universal protocol for surrender. American infantry appeared from multiple positions simultaneously, weapons trained but not firing, professional and efficient in their search and disarmament procedures. Richter noticed the bazooka team, among them, 2 young soldiers who looked barely old enough to serve, their simple steel tube having accomplished what no Sherman had managed in 3 weeks of combat. An American lieutenant, speaking surprisingly competent German, asked if Richter's crew required medical attention. Hoffman's field dressing was replaced with proper bandages from American medical supplies, and within 20 minutes, Richter found himself riding in a truck toward a prisoner collection point, his war effectively over. But one image remained burned into his memory with absolute clarity. The bazooka, lying across the lap of its gunner in the truck bed, was scarred and worn from obvious field use. No precision manufacturing, no sophisticated optics, no complex mechanisms, just a steel tube with a battery-operated trigger and crude iron sights that any farm boy could learn to use in an afternoon. And this simple device, costing $18 to manufacture, had rendered meaningless the 48 tons of sophisticated German engineering that Richter had commanded. The Americans hadn't beaten German armor through superior technology. They had redefined the parameters of success, optimizing for variables that German doctrine considered irrelevant. Range didn't matter when engagement distances were measured in meters instead of kilometers. Precision didn't matter when firing at tank-sized targets from 50 meters. Frontal protection didn't matter when infantry could approach from any angle the terrain provided. The Panther remained superior in every specification that German engineers measured, but those specifications had become strategically meaningless in combat, conditions that American weapons were designed to exploit. In the prisoner collection point outside Avranches, Richter encountered other Panther commanders, men who had survived the Falaise pocket through luck or skill, or some combination of both. They compared experiences, shared tactical observations, and gradually assembled a comprehensive picture of how American bazookas were employed in hedgerow warfare. The weapon appeared in American infantry companies at densities that German intelligence had underestimated. Initial reports suggested 3 to 4 bazooka teams per company, but survivors reported encountering 6 to 8 teams in some engagements. The Americans deployed them aggressively, using terrain and coordinated movement to position teams within effective range before German tanks could respond. Suppressive machine gun fire forced bazooka teams to ground temporarily, but the weapon's 2-man crews could relocate quickly and re-engage from different positions. Most disturbing were accounts of American tactics that specifically exploited Panther vulnerabilities. Infantry would fix German tanks with frontal fire, forcing the crew to button up and focus forward, while bazooka teams maneuvered into side positions using hedgerows for concealment. The shaped charge warheads achieved high success rates against side armor, with multiple reports of catastrophic penetrations that killed crew members and ignited ammunition. Even non-penetrating hits often damaged external equipment, destroyed periscopes, or created spalling that injured crews and degraded fighting capability. German tactical responses proved inadequate. Adding spare track links to turret sides provided marginal protection, sometimes detonating shaped charges prematurely, but often simply adding weight without preventing penetration. The Schürzen side skirts, originally designed to defeat Soviet 14.5mm anti-tank rifles, offered essentially no protection against bazooka warheads. Multiple Panthers had been destroyed despite having full skirt armor installed. The 5mm steel plates were simply too thin to trigger shaped charges at distances that would prevent penetration of the main armor. Infantry support, the doctrinally correct solution, was increasingly unavailable as German formations dissolved under Allied pressure. Even when Panzer grenadiers were available, the hedgerow terrain favored defenders. American infantry could remain concealed until German armor passed, fire their bazookas into side armor, and exfiltrate before German troops could locate and suppress them. The traditional combined arms approach, where tanks and infantry mutually supported each other, required coordination and communication that became impossible in the chaos of hedgerow combat. Hauptmann Werner Schmidt, a battalion operations officer captured at Mortain, provided Richter with broader strategic context during their time at the collection point. American bazooka production had reached scale that German planners had not anticipated. Intelligence estimates suggested over 476,000 launchers had been manufactured by mid-1944, with monthly production still expanding. The ammunition production was even more staggering, with millions of rockets stockpiled for use in Europe and the Pacific. This industrial capacity meant that American forces could employ bazookas with almost reckless abundance. Where German doctrine emphasized ammunition conservation and careful shot selection, American infantry could fire multiple rockets at single targets, accepting miss rates that would be unacceptable with scarce German Panzerfaust rounds. The psychological impact on German armor crews was cumulative and devastating. Every advance through hedgerow country became an exercise in suppressed terror, knowing that invisible infantry with portable rockets could appear from any direction. Schmidt mentioned an intelligence report from the Eastern Front that had reached him before his capture. Soviet forces had begun receiving American bazookas through Lend-Lease shipments, supplementing their own anti-tank capabilities. The implications were profound. German armor would face this threat on both fronts simultaneously, with no tactical solution that could be universally applied. The Panther's design, optimized for frontal engagement at long range, was fundamentally mismatched to combat environments where close-range side shots dominated tactical outcomes. The weeks in prisoner camps provided Richter with time to process the transformation he had witnessed. German military culture emphasized technical excellence, precision engineering, and the belief that superior equipment operated by well-trained personnel would overcome numerical disadvantages. This philosophy had served Germany well in the early war years, when quality advantages compensated for smaller industrial base. But by 1944, the strategic equation had shifted irreversibly. American industrial capacity, combined with a willingness to accept good enough solutions that could be mass-produced, generated overwhelming numerical superiority across all weapon categories. The bazooka represented this philosophy in its purest form, a weapon that sacrificed German ideals of precision and technical sophistication for universal availability and ease of use. The result was tactically decisive in terrain that favored ambush and strategically dominant through sheer numbers. Other German prisoners, tankers from Tiger and Panzer IV units, reported similar experiences. The bazooka threat was universal, affecting all German armor regardless of type. Tigers, with their heavier armor and reputation for invulnerability, proved just as vulnerable to side shots from shaped charge weapons. The psychological impact was particularly severe among Tiger crews, who had grown accustomed to technical superiority that made them nearly immune to frontal attack. Discovering that a two-man infantry team with a crude tube could destroy their 92-ton tank with a single well-placed shot shattered assumptions about armored warfare that had sustained German morale through years of combat. The mathematical truth was unavoidable. German armor had been optimized for battles Germany no longer fought. Open terrain engagements at long range, where superior German optics, gun performance, and frontal armor provided decisive advantages, had given way to close combat in urban areas and restrictive terrain, where those advantages became irrelevant. American doctrine, emphasizing distributed anti-tank capability and accepting higher loss rates in exchange for numerical superiority, proved better matched to actual combat conditions in Western Europe. Richter learned that his Panther 337 had been recovered by American forces and shipped to Aberdeen Proving Ground in Maryland for technical evaluation. German tanks captured in serviceable condition were subjected to systematic testing that analyzed every aspect of their design, performance, and vulnerability. The shaped charge penetration that had killed Steiner and destroyed the tank became data points in American armor development, informing future anti-tank weapon design and tank vulnerability assessments. This final indignity somehow completed the transformation Richter had undergone since that August afternoon, when 3.4 pounds of American explosive ended his war. The Panther he had commanded with pride, maintained with Germanic thoroughness, and trusted with his life, had become a museum piece, a teaching aid for the nation that had defeated it. The technical superiority that German engineering had achieved was real and measurable, but strategically meaningless when confronted with American mass production and tactical flexibility. Years later, after repatriation to West Germany and resumption of civilian life, Richter would read technical analyses of World War II armor battles that quantified what he had experienced viscerally. American bazookas accounted for approximately 19% of all German tank losses in Western Europe, a proportion that seemed impossible given the weapon's modest penetration capability and limited range. But the statistic reflected tactical realities that pure technical specifications couldn't capture. The bazooka's success wasn't measured in armor penetration or maximum range. It was measured in the universal distribution that put anti-tank weapons in the hands of every infantry squad. The psychological impact that made German tankers treat every meter of terrain as potentially lethal, and the industrial capacity that produced weapons faster than combat could consume them. American factories manufactured bazookas at rates that exceeded German tank production by factors of 100 or more, creating a distributed threat that German tactical doctrine had no answer for. The Panther remained, by objective technical standards, one of the finest tanks produced during World War II. Its combination of firepower, armor protection, and mobility represented the peak of German design philosophy. But that philosophy had optimized for variables that proved less important than American planners' emphasis on availability, simplicity, and mass production. In hedgerow terrain, in urban combat, in any environment where infantry could approach within 100 meters, the technical advantages of German armor became tactically meaningless. Richter understood, with the clarity that only defeat provides, that his crew had been killed not by superior American technology, but by superior American strategy. The bazooka wasn't a better anti-tank weapon than German Paks or Panzerfausts when judged by traditional metrics. It was simply more available, easier to use, and better matched to actual combat conditions in Western Europe. The Americans had won the strategic battle by redefining what success meant, optimizing for variables that German doctrine ignored. The final irony appeared in post-war analysis of German anti-tank weapons development. German engineers, after capturing American bazookas in North Africa during early 1943, had reverse-engineered the concept and produced their own version, the Panzer. The German weapon used an 88mm warhead compared to the bazooka's 60mm diameter, delivering superior armor penetration through larger-shaped charge. German precision engineering had improved on American design, creating a more powerful weapon that reflected Germanic technical values. But production of Panzer never approached bazooka numbers. German manufacturing, strained by Allied bombing and chronic material shortages, managed approximately 300,000 Panzer during the entire war. American factories produced more bazookas in a single month than Germany manufactured of their superior weapon in 3 years. The technical improvement was real, the strategic impact negligible. This pattern repeated across German weapons development. Superior engineering, better individual unit performance, more sophisticated technical solutions, all achieved at costs that made mass production impossible. American weapons were frequently inferior by German technical standards, but appeared in quantities that made qualitative comparisons strategically meaningless. The Sherman tank, the bazooka, even the jeep that German soldiers admired and stole whenever possible, all represented this philosophy of good enough, produced in overwhelming numbers. Richter's experience crystallized a truth that German military leadership struggled to accept even as their forces collapsed. Technical superiority, the bedrock assumption of German military culture, was a necessary but insufficient condition for victory. Without the industrial capacity to produce superior weapons in sufficient numbers, without tactical doctrine that could employ those weapons effectively in all-terrain conditions, without strategic flexibility to adapt to changing circumstances, technical excellence became merely expensive failure. The Panther tank, viewed from this perspective, represented both the peak and the end of a particular approach to armored warfare. Its designers had created a machine that excelled at everything German doctrine valued: frontal armor protection, long-range firepower, precision engineering, crew protection in planned engagements. But American tactical doctrine, informed by industrial philosophy that emphasized distributed capability over concentrated excellence, had rendered those values less important than availability, simplicity, and ease of use. In November 1945, 7 months after German surrender, Richter received notice that he had been selected for denazification screening preliminary to release from prisoner status. The process was perfunctory for Wehrmacht soldiers who had not been party members, and within weeks he found himself free in the American occupation zone, without employment, without prospects, with nothing but memories of a war that had consumed 6 years of his life. He never commanded another tank. The skills that had sustained him through 3 years of combat, the detailed knowledge of armor penetration mechanics, gunnery calculations, tactical movement principles, all became obsolete in a world where German armor was scrap metal and German military expertise was politically suspect. He found work eventually, first as a laborer clearing rubble in Stuttgart, later as a maintenance technician in a manufacturing plant that produced consumer goods for export to America. But certain images remained with absolute clarity: the curved gun mantlet of his Panther, 100 millimeters of cast armor that should have deflected any attack; the simple steel tube of the American bazooka, crude and unimpressive, carried by soldiers barely old enough to shave; the sudden thump when the shaped charge warhead struck turret side armor, followed by the screaming and the fire and the knowledge that every technical advantage had failed simultaneously. Richter never discussed these memories except with other veterans who shared similar experiences. German society in the 1950s had little appetite for detailed discussion of military defeat, and Richter had no desire to relive the trauma publicly. But in private conversations, with men who had commanded Tigers or Panthers or Panzer IVs, a consensus emerged about what their generation had witnessed. They had represented the old way, the German way, where technical excellence and superior engineering were expected to overcome numerical disadvantages. They had trained for years, maintained equipment with obsessive precision, employed tactics refined through centuries of Prussian military tradition, and they had been defeated by adversaries who asked different questions, optimized for different variables, and succeeded through approaches that German military culture found philosophically offensive. The bazooka, more than any other weapon, symbolized this transformation. It was inelegant, imprecise, limited in range and penetration, but it was everywhere, in the hands of every American infantry squad, destroying German tanks with casual efficiency that contradicted all assumptions about armored warfare. The weapon's very crudeness enabled its strategic effectiveness, because simplicity permitted mass production and universal distribution that German precision engineering could never match. American soldiers, Richter learned from post-war contacts, called the bazooka one of their tools of victory, along with the atomic bomb, the Jeep, and the C-47 transport aircraft. The assessment was accurate, not because the bazooka was technically superior to German anti-tank weapons, but because it represented a fundamentally different approach to industrial warfare. Where German doctrine sought quality through precision, American industry achieved victory through quantity. Where German training emphasized elite performance by specialist crews, American distribution gave basic capability to every unit. The transformation extended beyond weaponry to the entire philosophy of industrial warfare. German factories, operating under constant Allied bombing, struggled to maintain production of complex weapons systems that required specialized materials, precision manufacturing, and skilled assembly. American factories, protected by ocean barriers and powered by vast industrial infrastructure, produced adequate weapons using standard materials and semi-skilled labor at rates that overwhelmed German output by factors of 10 or more. Richter understood, decades after the events, that he had witnessed not merely military defeat but the obsolescence of an entire approach to warfare. The Panther represented the culmination of a design philosophy where individual weapons were optimized to maximum technical performance, regardless of production complexity. The bazooka represented its antithesis, adequate performance achieved through simplicity and produced in overwhelming quantities. History had rendered its verdict. The simpler approach won. The statistics that emerged from post-war analysis confirmed what Richter had experienced in Normandy's hedgerows. American bazookas destroyed or disabled over 2,000 German armored vehicles in Western Europe, achieved kill rates that compared favorably with much heavier anti-tank guns, and forced German tactical doctrine to adopt defensive postures that surrendered initiative to Allied forces. The weapon's success was measured not in technical specifications, but in tactical flexibility and strategic availability. German armor, by comparison, achieved impressive tactical victories through superior firepower and protection, but couldn't prevent strategic defeat. Panthers destroyed Sherman tanks at ratios approaching 5-to-1 in open-terrain combat, but American industry replaced losses faster than combat, consumed them, while simultaneously arming infantry with weapons that negated German armor advantages in close combat. Technical superiority became strategically meaningless when confronted with numerical superiority and tactical flexibility. Richter's final reflection, formed over decades of processing his wartime experience, concerned the nature of engineering excellence itself. German technical culture valued precision, sophistication, optimization of performance parameters to theoretical limits. These values produced remarkable achievements: the Panther's sloped armor, the Tiger's impenetrable frontal protection, the optical systems that allowed German gunners to engage targets at ranges Allied crews couldn't even detect. But these achievements came at costs that industrial warfare couldn't sustain. Complex weapons required specialized production, limited output, extensive training, and careful maintenance. When Germany faced adversaries with vastly superior industrial capacity, technical excellence became a luxury that prolonged defeat rather than preventing it. The bazooka, with its offensive simplicity and crude effectiveness, represented the practical wisdom that won wars, not by being better in laboratory conditions, but by being good enough in sufficient quantities. The afternoon sun cast long shadows across the Stuttgart factory floor where Richter worked, decades after his war had ended. Young Germans, born after the surrender, operated machinery that produced consumer electronics for export to America and Britain. They knew nothing of Panther tanks or bazookas, of shaped charge penetration or armor angling calculations. Their Germany built cars and appliances rather than weapons, and prospered through trade rather than conquest. Richter recognized this as appropriate, even necessary. The values that had made him an effective Panther commander, precision, technical excellence, sophisticated tactical thinking, served better in peacetime manufacturing than in armored warfare. Germany's post-war economic success derived from applying engineering skill to productive purposes, creating quality consumer goods that competed successfully in global markets. The same attention to detail that had gone into Panther tank design now produced Mercedes automobiles and Siemens electronics. But sometimes, watching American tourists browse Stuttgart's shops, Richter remembered the weight of a bazooka across a young soldier's shoulders, the crude simplicity of its design, the casual efficiency with which it had destroyed his Panther and ended his war. That memory contained a lesson he never forgot and rarely spoke. Technical superiority means nothing without the industrial capacity to produce it in sufficient quantities, the tactical doctrine to employ it effectively, in all conditions, and the strategic wisdom to optimize for variables that matter in actual combat rather than theoretical specifications. The Americans had understood this instinctively, or learned it quickly through pragmatic trial and error. Their bazooka was inferior to German Panzer by every technical metric, but appeared in quantities that made comparison meaningless. Their Sherman tanks were vulnerable and underpowered compared to Panthers, but rolled off assembly lines at rates that overwhelmed German production. Their industrial philosophy, emphasizing adequate performance through simplicity and mass production, proved decisively superior to German pursuit of technical excellence at any cost. Richter died in 1978, aged 57, of complications from the fragment wounds he had received in Normandy 34 years earlier. His obituary in the Stuttgart newspaper mentioned his military service briefly, noting he had been a tank commander during 18C, the war. No details were provided about the Panther he had commanded, the crew members he had lost, or the lessons he had learned about the nature of technical excellence and industrial warfare. But those lessons, learned in fire and blood in a Normandy hedgerow, represented truths that transcended individual experience. The Panther was the finest medium tank produced by any nation during World War II when judged by technical specifications. The bazooka was a crude weapon that violated every principle of German engineering philosophy. Yet the bazooka won, not through superiority in laboratory testing, but through availability in combat conditions where German technical advantages became irrelevant. This reality, more than any specific tactical defeat, explained German armor's failure in Western Europe. They had built the right weapons for the wrong war, optimized for conditions that no longer existed, valued specifications that proved less important than metrics German doctrine ignored. American planners had asked different questions and received revolutionary answers, not through superior technology, but through superior understanding of what actually mattered when industrial powers fought total war. The Panther's legacy lived on in post-war tank development, influencing designs from multiple nations that adopted its sloped armor principles and high-velocity gun concepts. But the bazooka's legacy was equally profound and perhaps more fundamental. It established the template for man-portable anti-tank weapons that gave infantry genuine capability against armored vehicles. This distributed lethality transformed battlefield dynamics, making armor vulnerable in environments where previous doctrine assumed tanks were supreme. Modern anti-tank guided missiles, recoilless rifles, and rocket-propelled grenades all descend from concepts that the bazooka first demonstrated operationally. The shaped charge principle, the shoulder-fired launcher, the two-man crew, the emphasis on simplicity and mass production over technical sophistication, all became standard features of infantry anti-armor capabilities worldwide. The crude tube that destroyed Richter's Panther established patterns that defined anti-tank warfare for generations. The Panther itself influenced post-war tank design, primarily through negative lessons. Its complex final drive system, prone to failure under combat stress, taught designers that sophisticated engineering must serve reliability first. Its weak-side armor, devastating in hedgerow combat, demonstrated that protection had to be balanced across all aspects, not concentrated in frontal arc. Its precision manufacturing requirements, which limited production even when Germany needed maximum output, proved that design complexity was itself a strategic vulnerability. These lessons were painful and purchased at costs measured in tens of thousands of casualties and billions of Reichsmarks. But they represented genuine learning that informed subsequent development. Post-war tanks from all nations emphasized reliability over raw performance, balanced protection over frontal-only armor, and manufacturing simplicity over technical sophistication. The Panther's failures taught lessons as valuable as its successes. For Richter, the ultimate meaning of his experience crystallized in a single image that haunted his memory across 3 decades. A 19-year-old American soldier, barely trained, carrying a crude steel tube that cost less than Richter's monthly pay, destroying 48 tons of German engineering excellence with a single 3-pound rocket. That moment contained everything important about industrial warfare, technical competition, and the nature of victory when industrial powers fought without limits. German engineering had produced a tank that excelled at everything German doctrine valued. American industry had produced a weapon that negated those advantages through simplicity, availability, and tactical flexibility. The Panther represented old thinking, where quality would overcome quantity, where technical superiority would decide outcomes, where sophisticated engineering would triumph through inherent excellence. The bazooka represented new reality, where adequate solutions produced in overwhelming numbers defeated perfect solutions available in limited quantities. History's verdict was clear and final. The Panther was magnificent. The bazooka was everywhere. Everywhere won. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.